Why don't I flinch? Because the laws of science differ fundamentally from all other. My face.
Question form. The diagram below shows two trolleys connected by means of a string. Trolley P has a mass of 400 grams, while trolley Q has a mass of 600 grams. Again, remember guys, generally grams must be converted to kgs, so be on the outlook. When the trolleys are released, it takes the spring 0.25 seconds to unwind to its natural length. Immediately after the spring is released, trolley P moves west at 6 meters per second. Okay. State the principle of conservation of linear momentum in words. The total linear momentum of an isolated system remains constant. Okay, that one you should also remember one is one of those definitions. 4.2 says calculate the velocity of the trolley Q immediately after the spring is released. 4.3 says calculate the magnitude of the force that trolleys exert on each other when the spring is released. Let's start with the velocity immediately after. So generally, again, when you see questions that say state the principle of conservation of linear momentum, and then next you're asked to calculate, you might be using that in the follow-up calculation. So the total momentum, total P initial, should be equal to the total P final. What is the total P initial? So these trolleys are initially at rest, so the total momentum should be 0. So since we are dealing with momentum vector, we have to choose which direction is positive and which direction is negative. I'll make east positive and west negative because I'm used to the east being positive. Not that it's a rule, but I'm just used to it. So P moves west at 6 meters, so that velocity is now negative. So P, the mass of P is 0.4. So the total final momentum should be the mass of P times the velocity of P plus the mass of Q times the velocity of Q. Continuing the calculation, 0 is equal to mass of P, we're told it's 400 grams, which is the same as 0.4 times west is negative. So it's negative 6 plus mass of Q is 0.6 and we don't know velocity VQ. Okay, so 0.4 times negative 6 is now negative 2.4 plus 0.6 V of Q. So bring the negative sign, this side, number this side becomes a positive 2.4 is now equal to 0.6 of VQ. Now, what is VQ going to be? 4 meters per second. In which direction? East. Because it's a positive number. Okay. The next one says, so this is, let's put there 4 east. Next question says, calculate the magnitude of the force that the trolleys exert on each other when the spring is released. Now, to calculate force generally involving momentum, because this question is about momentum. The first question says law of conservation of linear momentum. So generally, to calculate force using the idea of momentum, we need to use the idea that force is the rate of change of momentum. Now we can either use P or we can use Q to calculate that force, because again, according to Newton's third law, the force should be the same. Okay, let's start by using P. If we use P, we're going to say the F net is equal to, what is the delta P? Final momentum minus initial momentum over time. What is the final momentum? Well, the final momentum, we know the velocity is 6 and the mass is 0,4. So it's going to be 0,4 times a negative 6 minus initial momentum was 0 all over 0,25. Okay, this would give us what? A force of negative 9,6 newtons. So in this case, the negative tells us that this force that acts on P pushed P in this direction. And this can only be the force from Q. So Q pushes P in that direction. Okay? So with a force of 9,6 newtons. Since we're interested in the magnitude, we can leave it as a positive 9,6. If we use Q, the same idea, F net is mvf minus mvi over delta t. We will get 0,6 times 4 minus 0 all over 0,25, and we get a positive 9,6 newtons, which means the force on Q is in this direction, and this force is coming from P. So the force that these trolleys exert on each other is 9,6 newtons.